So this section 1.2 begins with factoring. And for factoring, that's something that you should have talked about already in Algebra 1 and Algebra 2. It should be something that you're fairly familiar with. So I don't really feel the need to go through this first page. The first page is just discussing different things about like what is a term, what is a factor. So take some time, read through the front of the page. If you have any questions, let me know. But I'd like to go ahead and jump into the math. So looking at the second page, this first example, when we're talking about factoring, when we want to factor this, what you're going to do is you're going to look for terms. This is, remember, the A term and the B term and the C term. So what you're looking for are things that multiply to the coefficient of the A times the C and add up to the coefficient of the B. So you're looking for things that are factors of 10 that add up to -7. Well, hopefully that's something you can do in your head at this point. Factors of 10 that add up to -7 are 5 and 2, and they both have to be negative because your B term is negative. So this is going to be x minus 5, x minus 2, and you are done and completely factored. So that one should have been pretty simple. Hopefully that's really standard for you and you can do that in your head. Take a look at B. B, they want you to factor. There is not a pattern that matches this factor group. So there's not anything where if it's squared, you're missing the B term and it's addition. So this one is unfactorable. So this one cannot be factored. You might be familiar with a pattern that looks like this. Hopefully you're familiar with this, that there's a pattern that says this, where if you have something squared minus something squared, which is called difference of two squares. So if this addition sign had been minus, then you could have written it this way, as x minus 4 and x plus 4. But since it was addition, this pattern doesn't work. So this is actually not factorable. So cannot be factored. Nothing we can do to that guy. Take a look at C. The first thing that I see is that they're all divisible by 4 and they're all divisible by x. So I'm going to take the 4 out and I'm going to take the x out. And because my highest degree term is a 3, I really always want my highest degree term to be positive. So I'm going to actually divide everything by -4. So I'm going to take -4x out. And rewrite it in terms of descending exponent. So you want your biggest exponent first. So this term is going to go first because it was a 3. When I divide it by -4x, that's going to give me x squared. The next highest term is this one. When I take the -4x out, I get plus x. And when I divide the 24x by -4, I get -6. Okay? So now this thing right here is also factorable because we need things that multiply to -6 that add up to 1. So I'm going to keep the -4x. Things that multiply to -6 that add up to 1, that's 3 and 2. So this is going to be x plus the 3 and x minus the 2. So that's how that guy factors. Okay, looking at the next one, letter D. Letter D is all in terms of variables, but that's okay. It's still the same pattern. You'll notice that they both have at least one u in common and they at least have one v in common, so I'm going to take that out first. So I'm going to take out the u and the v. That leaves me with u squared minus v squared. This one then follows that difference of two squares pattern that I was talking about up here, where if you have something squared minus that same something squared, you can split it up into two factors of their square roots. So this one, the uv in the front stays. And this guy splits up into u plus v and u minus v. So that's that one factored. Okay. Letter E, you'll notice again that they have some things in common. In fact, they all have at least a 2x in common. So I'm going to take that out first. So 2x, when I divide this by 2x, I get 9x squared. When I divide this by 2x, I get 6x. When I divide that by the 2x, I get 1. Okay, and then at this point, whenever you have a coefficient that's not 1, a lot of different people have different methods of how they want to factor things. Some people do something called split the middle. Some people like to use the box to factor. I like to use something called bottoms up, so that's what I'm going to use throughout these videos. But please feel free to use whatever kind of factoring method that you like to use that you already know how to do. So I'm going to need things that multiply to 9 and add up to 6. Well, things that multiply to 9 and add up to 6 are going to be 3 and 3. But because I'm multiplied by this 9 and it changed the value of this, unlike on the ones that I did earlier where the coefficient was 1, I have to divide this 9 back out. Well, 9 doesn't go into 3 evenly, but this fraction does reduce to 1/3. So in the bottoms up method, anytime you're left with a fraction, whatever number is in the denominator of the fraction moves up and becomes the coefficient on the x. So this factor that's 1/3 tells me that that factor, the 3 moves up, so this is 3x, and it's positive, so plus 1. This factor is also the 3 moves up, so 3x, the 1 is positive, so plus 1. On the AP test, they'll write it this way because you have 2 of the same factor, so they'll call this 3x plus 1 squared. Okay, so again, hopefully, if this method of factoring doesn't make sense, you're more than welcome to use any method you want. The box, do it in your head if you can. Split the middle, whatever method it is that you use to factor. Look at F. F is written not in the correct order, and there's some things that they have in common, so I'm going to take that out first. They don't all have a variable in common, but they are all divisible by 2. So if I take out the 2, that leaves me with 4x squared minus 4x, because this one comes in front, and then minus the 3. So again, I'm going to do the same thing. So I need things that multiply to negative 12 that add up to negative 4. So that's going to be negative 6 and 2. And again, I multiplied by this 4, so I'm going to divide it back out. These fractions reduce. This one's 1/2, and this one's negative 3/2. So this factor becomes 2x, and the 1 is positive, so plus 1. And this factor becomes 2x, and the 3 is negative, so minus 3. So that's F factored. Okay, let's take a look at G. These don't have anything in common, so I'm going to go back and just factor straight from there. If you use your calculator, 35 times 12, or times negative 12, is going to give you negative 420, and we need things that multiply to negative 1. So if you go through and you find factors of 420, you know that they're going to have to be really close together. Well, I know that 21 times 2 is 42, so it makes sense to me that 21 times 20 would be 420. So this is going to be negative 21 and positive 20. And we have to again divide by that 35. It doesn't go in evenly, but it reduces. This is what? They're both divisible by 7, so negative 3/5. And this one, they're both divisible by 5, so this is 4/7. So this factor is 5x minus 3 and 7x plus 4. Okay. Look at H. Anytime you have 4 terms, you want to do something called factor by grouping. So you're going to group the first 2 terms together and group the second 2 terms together. You want to look and see what they have in common. So these 2 both have in common an x squared, so I'm going to take that out. That leaves me with 3x plus 1. These 2 both have in common a 3x, they're both divisible by 2, right? And they're negative, so I'm going to take the negative 2 out. So if I divide this by negative 2, that leaves me with 3x. If I divide this by negative 2, that leaves me with 1. So notice that they have the same factor. So you can take that one out. And then your other factor is just whatever the coefficients are, so whatever's left. So this is x squared minus 2. And then sometimes on the AP test, they'll leave it like this. And sometimes on the AP test, they'll look at this, and this is technically difference of 2 squares. The square root of x squared is x. The square root of 2 is the square root of 2. So sometimes they'll actually split that up, and they'll say that this is x plus the square root of 2 and x minus the square root of 2 following that difference of 2 squares pattern. So it just kind of depends on what they were to ask you for. They wouldn't want this answer on a free response, but they would definitely want it on a multiple choice probably. Okay? And then look at this last one at letter I. Do you see that you can factor out a 2 out of this? And if we factor a 2 out of this term, it'll turn it into this term as well. So let me write that down and rewrite it. 5x minus 2 plus, I'm going to take the 2 out, and I'm going to put it in the front because that's where we normally put coefficients. And this would then be 5x minus 2. So you'll notice that these two terms, so this is a term and this is a term, because as you read through the front sheet, it told you that terms were separated by addition. So this term and this term separated by the addition, both have this 5x minus 2 in common. So I'm going to take that 5x minus 2 out of both terms. And in this term, if I take the 5x minus 2 out, that leaves me with x squared. And in this term, if I take the 5x minus 2 out, that leaves me with 2 times 3x squared minus 1. So I'm going to go ahead and distribute this 2 in and call this 6x squared minus 2. So I have these two terms now. In this one, I can combine these guys together. So this is 5x minus 2 times 7x squared minus 2. So hopefully factoring is something that you already know how to do, and this was just a little review of a couple of different techniques, the introduction of how I like to do factoring, the split of a couple of weird difference of two squared terms, and then factoring out something that doesn't really look like factoring. So hopefully that helped, and we'll hit the next examples in the next video.